So I hope you're feeling like you totally remember how to factor polynomials from grade 10. If you're not, talk to me. We'll get you extra practice. We'll try and come up with some different strategies for you to use so that we're confident in that, because now we're going to up the ante. We're going to make this a little bit more complicated. So this is 3.1, factoring polynomial expressions. And here is where we start learning something new. So example 1, factor the following quadratic expressions. Step 1 is just the same as before. We look for greatest common factor. In this particular case, we've got 2, -2, and -12. Those are all even numbers, so 2 goes into them beautifully. So we're going to factor out a 2. I'm not taking out a variable at all because I only have x showing up my variable in 2 out of the 3 terms of this trinomial. So I'm left with 2 divided by 2 is 1, so just x squared. I'm going to have negative x left as my second term and negative or subtract 6 as my third term. From here, it's factoring simple trinomials now that I don't have a coefficient in front of my x squared term. That 2 still tags along. It is now a third wheel. Do not drop that value that's out in front. So we've got x needs to be in both. I'm skipping over that crisscross method from before, and I'm just jumping straight into it. So factors of -6 could be -3 and +2. I chose -3 again because I want my greater number to be negative because I'm left with a negative value in the middle. -3 plus 2 is in fact -1, and so I can feel pretty confident. You can check your answer by multiplying it back out, like so. So we FOIL out our brackets, firsts, outsides, insides, lasts. That's what FOIL stands for, if you recall. So we've got x squared plus 2x minus 3x minus 6. Collect like terms. That's x squared minus x minus 6. And then we need to distribute that 2 back into the brackets, rainbow, and we've got 2x squared minus 2x subtract 12. And that does in fact match our first question, so we know we've done this right. But remember, this is my answer. That was just making sure I got the right answer. Moving on. What's different? If you said the fact that we're dealing with decimals, you are 100% correct. Okay, so decimals are a little bit scary for this example, but we want to get rid of them. How do we do that? We can actually factor out a 10th. So that's a little bit of a weird idea, but that's how we're going to take out these decimals. So originally we have 1. 1 divided by 0.1 is like 1 multiplied by 10. So we're actually left with 10x squared plus 14x minus 12. And all of a sudden, this becomes a slightly more manageable piece of information. But now we look at the inside and we're like, but there's common factors. So we got to factor those out too. So it's not just 0.1, it's 0.1 multiplied by 2, and we're left with 5x squared plus 7x minus 6. So this is starting to look a little scary. Now we can simplify this part so that it's at least just one value. 0.1 multiplied by 2 is just 0.2. But we're left with this trinomial that's not even a simple trinomial. It's still a complex trinomial. We have to factor it. So in this case, because I don't want to take up so much space, I'm going to do my guess and check crisscross for this particular question. Now, luckily, 5 does not have a lot of factors, so my left-hand side is pretty straightforward. It's going to be 5x and 1x. On the other hand, we've got subtracting 6. That's got a few different options. I don't want a huge number, though, because I'm only ending up with 7. 7's pretty close between 5 and 6, so I'm not going to multiply by a massive difference. So 5 times 2 is 10. 2 times 3 is 6, so I'd be dealing with 3 as my other factor of -6. Well, and we can even record why we've done this on top to keep it straight if we want. These two multiply together, these two multiply together. Now, to get my middle term, again, I follow my crisscross. And I get -3x. Make sure you don't read across, you read diagonally. And we get positive 10x. And when we add these together, we do, in fact, get 7x. So, great. This works, which means these are my two factors. And so I'm left with 5x minus 3 and x plus 2. So that particular question was a little bit scary. So whenever you're dealing with a decimal in your equation, factor out the decimal. Now, it sounds bizarre, but it's totally allowed. Just remember, like in this question, look for greatest common factors once you've taken out that decimal and broken it into a slightly less complicated trinomial. So let's move on. Dealing with fractions. I personally do not like dealing with fractions, but because this is just an expression, not an equation, I can't multiply in order to make it disappear because I'm not allowed to introduce anything new. So instead, I'm going to factor out that ugly fraction, and I'm going to work with whatever I'm left with. So just like factoring out that decimal, I'm going to take out my fraction. Now, remember that dividing by a fraction is like multiplying by the reciprocal. And the reciprocal is basically the value that needs to equal 1 when we multiply those two things together. So if I'm dealing with 1/4 and I need it to equal 1 by multiplying some value, I need something that's going to cancel out with my 4 or turn this into 4/4 is another way of thinking about it. Well, in that case, my reciprocal is that number 4. So dividing by a 4th, sure, you can think about it that way, or you can think about it as multiplying by its reciprocal, which is multiplying by 4. That's what we wanted to do in the first place, so awesome. A 4th multiplied by 4, like we said, is 4/4 or 1. So we're just left with x squared. -1 multiplied by 4 is -4x. And -3 multiplied by 4 is -12. That's a lot nicer to look at. That 1/4 is factored out, and we've multiplied by the reciprocal. And now we just need to factor our now simple trinomial. So yay, not even a complex trinomial, just a simple one. And we are more than able to do that. First term in both is just going to be x. Subtract 12 factors out to -6 and +2 in order to give me that negative middle term. And I'm done. That's it. Not as scary once we do that. So the key idea is that reciprocal is the value that you multiply the fraction by in order to make it equal to 1. And remember, 1 is like having the same numerator as the denominator. So whatever way of approaching it is, this is your definition of the reciprocal, and you can define it from there and figure it out in whatever way makes sense to you. We're going to move on to example D. Again, dealing with a fraction. We don't like fractions. We want to factor it out. In this case, to figure out my reciprocal, I'm dealing with a half. I need to multiply it by something to get it to equal 2 over 2 in this case, so that I'm still working with the same denominator. That's why I've set it up like that. Right now I've got a 1 in the numerator, so I'm going to multiply it by 2. So this guy right here is my reciprocal. So everything in this trinomial is going to be multiplied by 2. A half, 2 halves is another way of thinking about it, is a whole, so 1 x squared. Negative 1 multiplied by 2 is negative 2x, and subtracting 4. 4 times 2, though, is 8, so I'm subtracting 8. Again, it's a simple trinomial. Yay! So 1/2 x is your first term. And we're dealing with negative 8, larger negative value to give me a negative middle term when we add them. So it's negative 4 and positive 2. And again, you can check your answers. Example 2 looks a little bit scarier, but don't worry, we're going to use the exact same strategies. You'll notice that it looks scary because of those brackets, but we actually have the same thing in both brackets. So we're going to treat it as if it were another variable, as if that whole thing was x or that whole thing was y. If we were to do that, then we could focus on our coefficients and our constant, just like before. First step, in that case, is looking for greatest common factor. 12, 24, and 19 are all multiples of 3, so I'm going to factor 3 out of everything, and I'm left with 4. I'm going to use square brackets out here since I've got those extra round ones on the inside. X plus 2 squared plus 24 divided by 3 is 8. X plus 2 plus 3. Now, I could unfoil this, but again, not going to want to get into that just because I'm going to have too many brackets and things going on. It gets a little chaotic, so instead what I'm going to do is I'm going to do the crisscross method. So I need 4x plus 2 squared on this side, and I need to get 3 here. So my factors for 4x plus 2 squared are going to be maybe 2x plus 2 and 2x plus 2. Let's see if that works. Factors of 3 are 1 and 3, so we don't have a lot of options there. 3 and a 1. Let's see if this works. So we get 2 times 3 is 6, x plus 2. 2 times 1 is 2, x plus 2. Totals up to give me 8 x plus 2's, which is my middle term. That works out beautifully. So these are my 2 brackets. Don't forget the 3 out in front. But now to factor out this big beast of a trinomial, we've got 2, I'm still going to use square brackets, x plus 2 plus 3, and 2x plus 2 plus 1. Now, we are not done here because we still have so many brackets. We've got brackets inside our brackets. We want to simplify that. So 3 hangs out in front, third wheel. Make sure you write it every time. Inside my brackets, I'm going to distribute. And so I've got, that'll eliminate my brackets. I can actually use round ones again. I've got 2x plus 4 plus 3 and 2x plus 4 plus 1. I can simplify those further, and now I've got 3, 2x plus 7, and 2x plus 5. So that's one way of solving these kind of monstrous quadratic equations that have binomials inside of them. I'm going to show you another way to do it working with our next one. Different strategy. So strategy 2, I had said they kind of represent these binomials that are in brackets kind of can be represented by a variable. I can say y is, and that's exactly what I'm going to do here. Let y be 3x minus 4. Now every time I should be writing 3x minus 4, I'm just going to be writing y in its place. So it's going to look a little bit more manageable, at least for the factoring piece. So I've got 6. I'm going to keep it in red to keep track of it. So y squared minus 21y plus 15. Well, this looks like a regular trinomial now. I'm going to factor it just like that. So greatest common factor, again, actually ends up being 3. Leaves me with 2y squared minus 7y plus 5. From here, I'm going to factor it out, and I get 2y, keeping that y red, minus 1, and y minus 5. Now, if you're asking, why is it minus 1 and minus 5? The reason I did that is because although my constant is positive, which means I need to have two factors with the same sign, so negative times negative, positive times positive, because that middle term is negative, I know to use negatives instead of positives. So great, I look like I'm finished here. But because I had substituted out my actual variable along with some other information, now I need to plug that back in and solve for it. So that's where it starts to look the same as our previous question. We've got 3x minus 4 minus 1 and 3x minus 4 minus 1. Oop, not minus 1, minus 5. Be careful you don't make mistakes like that and just write the same thing twice. From here, distribute out 6x minus 8 minus 1, 3x, and we can already simplify this one, it's minus 9. So it's 6x minus, and we can factor out, that's going to be minus 9 and 3x minus 9. So my red flag here is that this one has extra factors. I've got 3 is common in this set of brackets and 3 is common in that set of brackets, so I can actually take those all out. 3 times 3, 2x minus 3, and 3 times x minus 3. But I can collect all those constants, this one, and this one. So my final answer, never put two negatives in a row, so indicate that we're moving over here. My final answer is going to be 3 cubed, which is 27 times 2x minus 3, x minus 3. So again, once you've started to simplify your initial factors with those extra binomials in them, look for signs of more greatest common factors, because initially it did only look like there was 1, 3 that was a greatest common factor. But once we multiplied it out, more kind of unveiled themselves. So example 3, we're getting close to the end, is looking specifically at another type of example. Any guesses? If you can read this, we're looking at our difference of squares again. What makes these questions a little bit different than our other difference of squares is the fact that we're dealing with decimals, like in example 3a, or we're dealing with fractions, like in example 3b. So the key thing to look for is we're still looking for perfect squares. So 9 is definitely a perfect square. X is a perfect square. We are subtracting, so that takes care of the differences part. Y squared is a perfect square. So now we're just looking at that decimal. Now, if it wasn't a decimal, if it was just 64, that is a perfect square. The fact that it has 2 decimal places is a red flag to me, because it means that it is also a perfect square. Because we need to go back, way back into decimal multiplying rules, which we might have learned a long time ago, or maybe we never learned them at all. But the key thing is that your product of decimals, if you multiply decimals, then your product will have the same number of decimal places as the total number of decimal places in your starting numbers. So just as a tangent to kind of consider, if we took 0.02 multiplied by 0.5, we would end up with, and actually we're going to change those. Let's turn this into a 3, so we don't end up with a 0 at the end. 0.03 times 0.05, we're going to end up with, well, 3 times 5 is 15, but there's 3 decimal places in total, 2 over here, 1 in this one, so I'm going to need 3 decimal places in my answer. Now you can put that into your calculator and check. You'll see I'm right, and this works every time. So if I have an even number of decimal places and I'm dealing with a perfect square, I can take half the number of decimal places, and that's where my answer should be. Now you're like, what on earth are you talking about, Ms. Conrad? I'll show you. To write the factors of difference of squares, we first start with our brackets. Our first term is easy enough to take the square root of, since they're both obvious perfect squares. So we've got 3x and 3x. Adding and subtracting to produce that difference and eliminate our middle term. We also know we're going to have y and y. The square root of 64 is 8. I have 2 decimal places, so each of the square roots should have 1 decimal place. So it's going to be 0.8 and 0.8. Now, if you don't believe me, check on your calculator. Take the square root of 0.64, and you will find that it is 0.8. Fractions, actually, in my opinion, for once, are the easier thing to deal with, because it's still just the whole numbers and you just take the square roots of them. So when I look at my first term, it's x squared, perfect square. 9 is a perfect square. It's just in the denominator. For my second term, 4 is a perfect square. 25 is a perfect square, so just in the denominator. So when I go to factor this out, I'm just going to take the square root of everything and leave it in the exact same position it was before, and you're good to go. So x squared becomes x, so x and x. The square root of 9 is 3, and then we add and subtract to get rid of that middle term. Square root of 4 is 2, square root of 25 is 5, 2/5. Now the reason this works is because we have that exponent law where we've got a fraction to the power of a is equal to your numerator to that exponent and your denominator to that exponent. In our case, what we're doing is we've got x and x squared and 9. And if you remember from last year, square root is the same thing as taking a half of that. So it's like x to the power of 2 multiplied by a half, and 9 to the power of a half, which is the same thing as, well, 2 times a half is 1, so that gives me x. A half is the same thing as the square root, so square root of 9 is 3. So that's how that works. And this is my answer. So of the two, I like fractions better than decimals, but you might have a different opinion. So let's try a couple more. See, we've got one value squared and another value squared. Great. They're two perfect squares. Even if it's a whole bunch, it's a binomial that's being squared, it's still being squared, so it's still a perfect square. So my first step, and this is where it goes back to the previous example, example 2, we've got 2x minus 1 is the square root. So we're going to stick it in both sets of brackets. 2x minus 1. Different signs to account for the fact that I'm missing my middle term, and I'm getting a negative for my last term, so opposite signs. And the square root of y plus 4 squared is y plus 4. Y plus 4. But just like in example 2, because we still have brackets inside brackets and constant terms that are not together, we are going to try and combine this as much as possible. So luckily, we don't have anything multiplying out in front of these brackets, so we can, except for this negative, so we can treat it like the negative is getting distributed. So we've got 2x minus 1 plus y plus 4 multiplied by 2x minus 1 minus y minus 4. Collect like terms within those brackets. We've got those two getting combined and these two getting combined. We cannot combine x and y because they're two different variables, so we're just going to combine constants. So we've got, I'll do this in black, 2x plus y plus 3, 2x minus y minus 5. And there's my answer. Those are the simplified factored versions. So the same principle applies here, but now we've got those numbers out in front. So we're going to just have another step in terms of distributing. Same rules still apply. It's still a difference of squares because 9 is a perfect square. This whole piece is squared, so it's perfect. 4 is a perfect square. S minus 2 is also squared, so it's a perfect square. So here we go. Brace yourselves. Square root of 9 is 3. The square root of this whole piece, the binomial squared, is the binomial itself. And I do the same in both brackets for my first term, because it's positive, so they should have the same sign. My second term have opposite signs, so that they produce a negative when they multiply. Square root of 4 is 2. Square root of a binomial squared is the binomial itself. And so we're left with these. But again, these are not pretty. We need to simplify with a lot of distribution. Most common mistake, missing this negative right here. So let's not do that. Let's see if I can manage. Sometimes I forget. 6t plus 6 plus 2s minus 4. And 6t plus, oops, not 6, 3, and 3 minus 2s plus 4. There we go. So busy worrying about that negative that I forgot 3 times 1 is 3, not 6. Now I'm going to collect like terms. Again, I've got different variables, so I'm not going to be able to collect them within the brackets, but I can collect constants. So I've got 6t plus 2s minus 1 and 6t minus 2s plus 7. And that's my answer. Last one. If you're feeling kind of confident, go ahead. If you're not feeling confident, that's okay too. We're gonna work through this one together because already I'm getting a red flag. 32 and 18 are not perfect squares. But they do have a greatest common factor. So, oh my gosh, adding another dimension. Greatest common factor. Take it out, throw it up front. I'm going to write it in blue so that I make sure I don't forget it. The greatest common factor of 32 and 18 is 2. The rest of it is going to be 32 divided by 2 is 16. X, oh, and I'll write all this in black. 32 divided by 2 is 16. X plus 2 squared minus 18 divided by 2 is 9. 2y minus 3 squared. Now I've got perfect squares. So I'm going to continue just like we did before. Square root of 16 is 4. Square root of a binomial squared is the binomial itself. It's the same in both brackets because I have a positive term out in front, so positive times positive. Square root of 9 is 3, so I'm going to put that in both. Square root of a binomial is the binomial itself. So not x. Don't change your variable because that'll make things different. I would have been able to collect like terms with my variables if I had changed that. And opposite signs to produce that negative, and also eliminate my middle term. That 2 is still hanging on for dear life. We are going to distribute our multipliers into their brackets. So we got 4x plus 8 plus 6y minus 9 in our first set of brackets. These can be round now. 4x plus 8 minus 6y plus 9. And the second one. And again, we're collecting like terms. So we have 4x plus 6y minus 1 and 4x plus 6y, minus 6y plus 17. And that is my final answer. So I know these look pretty monstrous. That's our last example, so this lesson is done. There are lots of practice questions, so check at the front of your booklet and that unit outline, see what you're supposed to work on, and definitely do your homework to get this mastered, because there's a lot of distributing and multiplying and manipulating these equations in the rest of the unit. So it's really important that we nail down these skills. If you get stuck, ask a classmate, see if you can find another video, rewatch this video, check your notes, or come talk to me.